So lesson 4, okay, when we were looking at the definitions effectively of the voltage potential difference, which is potential difference of current and of a resistance. Okay, so I think maybe we're better to start on page 3. Okay, so we have current. Now we know current is the flow of charge, okay, but effectively it is the charge divided by the time. It's the amount of charge passing a point in 1 second. So that's the charge divided by the time. So think of it, 40 coulombs passing 4 seconds. So the charge passing in 1 second, 10 coulombs in 1 second, okay, and that's 10 amps, and so on. So that's I is Q over T. Now, very important in this, for an exclamation mark, that is not in the tables, right? Over here, the voltage, okay, potential difference. Remember, potential difference is energy. So you're supplying energy to the charges, and we measure it with potential difference. So it's the energy per unit charge. It's the energy for every coulomb of charge that's required to move the charges from one point to another. Okay, so it is the work done, or the energy required per charge to move the charges from one point to the other. So if I say there's a potential difference of 6 volts across 2 points A and B, that means that 6 joules of energy is required to move the 1 coulomb of charge between those 2 points. So it's work divided by charge. Okay, so I think that should be okay. And finally, for Ohm's law, okay, Ohm's law, which we'll come back to, we're doing constantly, resistance is just the ratio of the potential difference divided by the current. Okay, and you're aware of that from junior cert, right? But we will be doing it in detail in current electricity. Interesting with the voltage, and we looked at this, okay, is that this is where the electron volt in the atom comes from, okay, right? Okay, if we rearrange, we get W is equal to QV, okay, and if the charge is a charge on the electron, and the voltage is 1 volt, you get a work done, okay, equals the charge on the electron, okay, so you have 1.6 by 10 to the minus 19 by that, so it's 1.6 by 10 to the minus 19 by 1, which is 1.6 by 10 to the minus 19 joules. So the work done is called an electron volt. The work needed to move 1 electron across 1 volt. Okay, so it takes a little bit of thinking about. We'll come back to it, don't worry about it. Okay, and if we go back to page 2 then, we have our definitions that are linked to this. So the potential difference, the work done in moving 1 coulomb between 2 points. So we have our definition, our formula that helps you there. Okay, and we can define the volt then. The potential between 2 points when is 1 volt. So the volt potential is 1 volt with 1 joule of work is moving 1 coulomb of charge. So it's just one of everything, a bit like we had back along in mechanics. So they're linked together. And EMF is a special name when you apply voltage to a full circuit. Okay, so really potential difference is between 2 points. The EMF of a whole circuit, which would normally be the power of the battery or the power supply that you're using, is called EMF for traditional historic reasons. Okay, so that's it. Very good. Thanks, man.